What if the third interstellar visitor ever discovered was not a comet, but a billion-year-old alien messenger? In the summer of 2025, a faint object designated 3I Atlas streaked into our solar system, and a controversial hypothesis immediately captured the world's attention. This was no ordinary rock. The idea of advanced alien technology made global headlines, but NASA quickly stepped in with a powerful, evidence-based response that settled the debate. So what did they find? Let's explore this together. The Atlas discovery in Chile. So, where does a story like this begin? It starts with our ever-watchful eyes on the sky. The story began on July 1, 2025, when the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a robotic survey telescope at the El Sos Observatory in Chile, detected a faint object with an initial apparent magnitude of plus 19.5. To put that in perspective, that's about 250,000 times fainter than what the human eye can see. When astronomers calculated its orbit, they saw something remarkable. Its path was hyperbolic with an orbital eccentricity calculated to be a staggering 1.8. In astronomy, any orbit with an eccentricity greater than 1 is unbound. This number confirmed it was moving at approximately 55 kilometers per second relative to the Sun, far too fast to be a member of our solar system. Astronomers quickly named it 3I Atlas. Initial estimates suggested it could be massive, between a few hundred meters and several kilometers across, making it potentially much larger than the previous two interstellar visitors. The discovery was a major success for the ATLAS network, which also includes telescopes in Hawaii and South Africa, proving its effectiveness in spotting these rare cosmic travelers. The detection of a third such object in less than a decade confirmed that these visitors are more common than previously thought, officially opening a new frontier in astronomy. Avi Loeb's controversial hypothesis. Here's where the story takes a sharp turn into speculative territory, thanks to a bold proposal from Harvard astronomer Avi Loeb. While most scientists saw a fascinating natural object, Loeb, known for his controversial work on Oumuamua, offered a different interpretation. In a scientific paper posted to the ArcSiv preprint server, Loeb pointed to the object's early lack of a visible coma and its trajectory. He suggested that if the comet continued to show no outgassing, or if its path deviated from a purely gravitational path without a visible tail to explain the push, it could be evidence of something artificial. He even raised the hypothetical possibility of malign intent, though he stressed this was an intellectual exercise meant to keep science open to radical possibilities. His argument, similar to the one he made for Oumuamua, hinged on the idea that any non-gravitational acceleration without a visible coma required a novel explanation. He proposed that a solar sail, a thin, lightweight craft pushed by the pressure of sunlight itself, was one such possibility that science should not be afraid to consider, however unlikely it might seem at first. The physics of radiation pressure are well understood, but for it to be effective, an object must have a huge surface area and an extremely low mass, characteristics not found in natural bodies. Media sensation versus scientific method. You can imagine what happened next. The words alien technology from a prominent Harvard astronomer ignited a media firestorm. The idea was captivating, offering a sensational explanation for a new cosmic puzzle. But this is where the rapid world of headlines collides with the methodical, patient pace of science. The scientific method isn't about finding the most exciting answer, it's about finding the one that best fits all the evidence. The broader astronomical community, while not dismissing Loeb's right to speculate, emphasized the need for patience and adherence to Occam's razor, the principle that the simplest explanation is often the best. Their stance was clear: we must first rule out all known natural phenomena before jumping to an extraordinary conclusion. The use of preprint servers like ArcSiv allows for rapid dissemination of ideas, but also bypasses the traditional peer review process, meaning speculative ideas can reach the public before they are fully vetted by other experts. Ultimately, the scientific consensus held that declaring an object alien required the elimination of every single possible natural explanation first, a very high bar that had not yet been met. NASA's comprehensive investigation. With the debate raging, NASA and its international partners marshaled their most powerful instruments. This wasn't a casual glance, it was a coordinated, multi-platform investigation led by Tom Statler, NASA's lead scientist for small bodies. The agency dedicated priority time on the James Webb Space Telescope, using its near-infrared spectrograph or NIR spec, to perform detailed chemical analysis of the gases in its coma. Simultaneously, the Hubble Space Telescope's Wide Field Camera 3 was used for high-resolution imaging to search for any faint dust or fragmentation events with its superior resolving power in visible and ultraviolet light. On the ground, a network of observatories, including the twin 10-meter mirrors of the Keck Observatory in Hawaii, began a long-term monitoring campaign to track its brightness and trajectory with pinpoint accuracy. The goal was to leave no stone unturned, to precisely measure its path to within a few milliarc seconds, to analyze its chemical composition, and to study its light curve for clues about its shape and rotation. This multi-wavelength, multi-observatory approach is, honestly, the gold standard in modern astronomy for characterizing a novel object. Comet behavior confirmed. So what did this powerful array of telescopes actually see? The answer was unambiguous and came sooner than many expected. As 3I Atlas drew closer to the Sun, crossing the orbital distance of Jupiter at approximately 5.2 astronomical units, which is about 483 million miles, the solar radiation began to warm its icy surface. Just as predicted by standard cometary models, it started to sublimate, behaving exactly like a comet. Astronomers watched as it developed a distinct coma, the fuzzy, gaseous atmosphere around its nucleus, which grew to over 50,000 kilometers in diameter. Shortly after, a classic tale of gas and dust began to form. Tom Statler summarized the findings. It looks like a comet, it does comet things, and the evidence overwhelmingly points to it being a comet. The observation of outgassing with a dust production rate estimated at over 50 kilograms per second provided the natural explanation for any minor deviations in its path, rendering the artificiality hypothesis unnecessary. This behavior began right around the frost line where water ice turns to gas, a telltale sign of a natural cometary body. Chemical composition analysis. But confirming it was a comet was just the beginning. The real prize was in its chemistry. A team led by Dr. Anjali Sharma, a planetary scientist at NASA's Goddard Space Flight Center, used the James Webb Space Telescope spectrographs to break down the faint light from the coma into its chemical fingerprints. The analysis revealed familiar substances like water ice and carbon dioxide, but with a major surprise. 3I Atlas had an unusually high ratio of carbon dioxide to water, measured at nearly 35%. This vital clue suggested the comet must have formed in an extremely cold region of its home star system, far out in its protoplanetary disk, where CO2 could freeze out in large quantities. Furthermore, analysis of the dust grains showed a polarization signature with negative branching at a phase angle of 22 degrees, suggesting a surface composed of very fine, porous, fluffy dust grains, a sign of a very pristine, unaltered body. This fluffiness implies the grains have not been heavily processed by heat or collisions, making them a near-perfect sample of their native environment. This chemical snapshot provides invaluable data for models of planetary formation in other star systems. Trajectory and safety assessment. With the "what is it" question settled, NASA also moved to definitively address any public concern about its path. The coordinated tracking campaign from both space and ground-based telescopes allowed for an extremely precise calculation of its orbit. The agency confirmed that 3I Atlas posed absolutely no threat to Earth. Its closest approach to our planet will be a very safe 1.8 astronomical units, which is about 273 million kilometers or 170 million miles away. Its perihelion, or closest approach to the Sun, is predicted for January 12, 2026, at a distance of 1.5 AU, placing it between the orbits of Earth and Mars. NASA's Planetary Defense Coordination Office used this as a perfect real-world test of their tracking systems, proving they can accurately predict the path of even novel interstellar objects with incredible precision. After it loops around the Sun, its hyperbolic trajectory will ensure it is flung back out into interstellar space, never to return. Its brief passage is a fleeting but precious scientific opportunity. Natural anomalies in cometary physics. The whole 3I Atlas controversy really boils down to a single fundamental question in science. Is an anomaly evidence of something artificial, or is it a sign of a natural process we haven't encountered before? Science almost always bets on the latter. Our own solar system is filled with comets that behave in bizarre ways. Take Comet 29 P. Schwarzmann-Wachmann, which can increase in brightness by over 15 magnitudes, a factor of 1,000,000, in just a few hours due to cryovolcanic eruptions. Another example was Comet C 2019 Y4 or Atlas, a different comet which unexpectedly disintegrated into multiple pieces as it approached the Sun, showing how fragile these icy bodies can be. The point NASA scientists made is that unusual traits are not automatic evidence of engineering. They are part of the normal, messy, and fascinating physics of icy bodies. These anomalies are not problems for science, they are the very data points that lead to new discoveries about how objects form and evolve. Thus, the unique chemistry of 3I Atlas isn't a paradox, it's a clue. Scientific value of interstellar visitors. So if 3I Atlas is not alien technology, why is it so important? Because interstellar comets are windows into other worlds. Each one is a preserved time capsule carrying the precise chemical and physical fingerprints of the environment where it formed. For 3I Atlas, the dominance of CO2 in its trajectory suggests it could be over 7 billion years old, originating from the Milky Way's thick disk, a population of ancient stars that existed long before our sun was born. By studying its isotopic ratios like the deuterium to hydrogen ratio in its water, scientists can get direct clues about the water in other primordial solar systems, a key factor in assessing the potential for life elsewhere. This is more than a curiosity, it is a preserved fragment of another planetary nursery. Future missions like the ESA's Comet Interceptor are being designed specifically to launch and wait in space, ready to chase down the next interstellar visitor for an even closer look. These objects represent a fundamental shift from studying other solar systems through the faint light of their stars to analyzing actual physical samples. Comparing 3 interstellar objects. To truly appreciate 3I Atlas, you have to place it in context with its predecessors. The first, Oumuamua, discovered in 2017 with an eccentricity of 1.2, was a complete enigma. It was small, rocky-looking, showed no visible coma, yet had a mysterious acceleration. The second, 2I Borisov, found in 2019 with a high eccentricity of 3.37, was almost the opposite. Its nucleus was about 1 kilometer wide, and it behaved like a classic comet, allowing for detailed study. 3I Atlas, with its eccentricity of 1.8, falls between these extremes. It behaves like a comet, which sets it apart from Oumuamua, but its distinctive chemical ratios make it stand out from a standard comet like Borisov. This growing diversity is forcing astronomers to create a new classification system for interstellar objects. The current rate of discovery suggests that at any given time, there are likely thousands of interstellar objects within our solar system, but most are too small and faint to detect. As our technology improves, we can expect to find many more of these cosmic messengers, each one adding another piece to the vast puzzle of our galaxy. In the end, Comet 3. I-Atlas isn't alien technology, it's a natural interstellar comet, a stunningly beautiful and scientifically priceless messenger from another star system, shedding gas and dust as it speeds through our cosmic neighborhood. The real story here isn't science fiction, but the incredible power of science itself to solve mysteries and reveal the universe's secrets. It's a rare glimpse of pristine material from another world, reminding us that the cosmos is far more diverse and fascinating than we can imagine. For more deep dives into the mysteries of our universe, don't forget to like, subscribe, and hit the bell icon. The universe always has another surprise waiting. Thank you for watching InnoVision Tech.